in the previous classes you have studied about rectangle. Rectangle is a two-dimensional figure, and what does it have? It has length and it has breadth. A perfect example of a rectangle would be a sheet of paper. Here, this is a rectangle. This would be its length and this would be its breadth. Now, suppose I take 500 of such papers, put them on top of one another, then what do I get? In addition to length and breadth, I get a third dimension which is called the height. Now, this has become a three-dimensional figure called a cuboid, which has in addition to length and breadth, it has height. So, how does this cuboid look like? How many vertices or end points does it have? It has 8 end points. 1, 2, 3, 4, 4 here, 4 here. It has 8 vertices. And how many edges or how many sides does it have? It has 12 sides. And most important, what we need to know for this particular topic, how many faces does it have? It has 6 faces. 1 face, 2, 3, 4, 5 and 6. It has 6 faces, each of which is a rectangle. Each of that face is a rectangle. And the pictorial representation of a cuboid looks somewhat like this. Now, when we say the dimensions of a cuboid are, say, 10 centimeter by 5 centimeter by 2 centimeter, that means this is the length, this is the breadth and this is the height. Now, suppose I want to gift this book to someone. So, I have to completely cover the surface. So, I need to know how much this surface is. So, that would be easy, right? So, what is this cuboid? How does its faces look like? It has 6 faces, each of which is a rectangle. So, all I have to do is find the area of those 6 rectangles and add them up. So, what I get will be called a total surface area. And then let us start calculating. Look at the first one. It is a rectangle. What are its dimensions? Length and breadth. So its area is LB. And how many LBs do we have? 1, 2. So we have 2 times length into breadth. That is 2 faces done. Next, look at this. Height and length. So what is the area of this triangle? This will be LH. So how many such faces do we have? 1, 2. So that is 2 times length into height. And then this one, height into breadth. How many such faces you have? 1, 2. So that is 2h into b. That is equal to, take 2 out, LB plus LH plus HB. And what will be its unit? We have discussed in the earlier classes also. If you add 2 centimeter plus 3 centimeter would be 5 centimeter. But then 2 centimeter into 3 centimeter will be what? It will be 6 centimeter square. So, whenever you have area, remember area is measured in square units. So, this will be, here we have taken, for example, we have taken this cuboid, no? So, this is centimeter. So, in this particular case, the total surface area will be centimeter square. It can be any square unit. Centimeter square, meter square, kilometer square. It can be anything. Now, consider this to be a room. So, first we consider this to be a box. Now consider this to be your room. You want to paint the walls, just the walls, not the roof, not the floor, just these 4 walls. Then which 2 rectangles do we lose? We lose the top, we lose the bottom. Or in other words, we lose the 2L into B. This was L into B, right? So we lose both the L into B. And then what do we get? We get 2LH plus 2HB, or in other words 2H into L plus B. And this area is known as the lateral surface area. In English, what do we mean by the word lateral? We say the ears. Our ears are lateral to our face. What does it mean? It means sideways. So he was known for his lateral thinking. It means anything that is sideways, not going straight. So if you take just the sides, you get what is known as the lateral surface area, that is 2H into L plus B. Now we come to a cuboid whose length, breadth and height are equal. Such a cuboid is called a cube. And instead of using 3 different terms to refer to its dimensions, we use just one term, side. So cuboid has all its sides equal. So then what will be its total surface area? Earlier with the cuboid we had 6 rectangles, and to find the total surface area we added up the areas of those 6 rectangles. But what you have here will be a square. All the 6 sides will be squares, and the area of one square is S square. So 6 such squares, 6S squared. And what will be the lateral surface area? There we had 4 rectangles. Here we have 4 squares. So this is 4x square. Now, do you remember in the previous class we started with a perimeter? What is a perimeter? Perimeter deals with this, the boundary of a figure. So what happens in the surface is none of perimeter's business. So it is just about the boundary, and it is measured in centimeters. So we need to find perimeter if we need to know maybe like framing a photo. So when you frame a photo, you need just this. Or fencing a field. So when you fence a field, you need to know just the perimeter. Or running along the boundary of a park. All of this means you have to find the perimeter. From that, we went to area. What is area? It is about the surface, and it is measured in square units, centimeter square, meter square, etc. And where do we apply area? Anything that has got to do with the surface. Painting, whitewashing, covering, all of that deals with area. Now another problem we have. What if we have to find out how much a 3-dimensional figure holds? How much water a tank can hold? Or if you have a big box, how many small boxes can you fit into it? So perimeter will not help you. It is just the boundary. Area will not help you. It is just the surface. But how do you find out what goes inside? You have to find something called the volume. The volume will tell you how much any body, suppose you have this cuboid, how much it can hold. That volume will tell you. And its formula is also very easy. Find the area of the top, multiply it with the height, you get the volume. So if you have a cuboid with length L and breadth B and height H, that is its volume. L into B, that will be the area of the top rectangle, and into H. So this will be the volume of a cuboid. And what about the volume of a cube? Volume of a cube, you remember, it does not have 3 different terms, just one, S cube. And then what will be it measured in? It will be measured in centimeter cube, meter cube, etc. And this volume it will actually tell you how much water a tank can hold, or if you have a big box, how many small boxes can you fit into it. All of this volume will tell you. Now we will go to some basic questions that we will see in this topic. Suppose you have a cuboid. Its dimensions are given by 10 centimeter, 5 centimeter and 2 centimeter. Please notice this is not the multiplication sign. This is how the dimensions are given. Usually they use this cross sign or the word by. 10 centimeter by 5 centimeter. It means the same. The length, the breadth, the height. A direct question. What is its surface area? Then you apply the formula. Then what do you have? A 50 here, a 20 here and a 10 here. That would be 80 and 160 centimeter square. Do not forget the unit. Now the second question is, suppose I have to whitewash this box and that comes with a cost. The cost is 2.5 rupees per 16 centimeter square. So what does that mean? Area and cost. That means for every 16 centimeter square, when the area is 16 centimeter square, the cost is 2.5 rupees. But then how much is your area here? It is 160 centimeter square. Then how much will be the cost? Suppose the cost is X rupees. Then what do? You cross multiply and then you get 160 into 2.5 is equal to X into 16. That means X is equal to 160 into 2.5 by 16, and that means cut 25 rupees. Do not forget we are asking about the cost. So that should come in rupees. So if you spend 25 rupees, you can paint this box. So this is the, usually you will not see it, it will also be 2.5 rupees per centimeter. What does per centimeter means? It means instead of 16, you are just talking about 1 centimeter. Per means for every 1 centimeter. So 2.5 rupees per centimeter square means you put 1 here. The rest of it is same. Now another one common question is, how is the surface area or the volume affected when a side is halved or doubled or tripled? So suppose you have a cube. Suppose its side is halved. That means it used to be 8, now it is 4. Or it used to be 16, now it is 8. Now how does it affect its surface area? It can be doubled, it can be tripled, or it can be halved. So suppose we are taking here that it is doubled. Okay? The side of a cube is doubled. That means it used to be S, but what is it now? It is 2S. So instead of S, put 2S here, and then what will you get? You will get 6 into 4S square. That means 24S square. That means the surface area is increased 4 times. If the side of a cube is doubled, the surface area increases 4 times. What happens to the volume? Volume is S cube. So but here instead of S, what do you have? You have 2S. That is equal to 8S cube. And what does that mean? The volume is increased 8 times. And what if it is halved? Instead of double, what happens if it is halved? Then what is the new surface area? Instead of 2S, you have s by 2 the whole square. That would be 6s square by 4. That would be, yeah, so 6s square by 4. This was the old surface area, and now what is the new surface area? It is that surface area by 4. And what about the volume? Instead of S, take this. So what is the new volume now? The old volume divided by 8. So this is yet another question that you can expect. The ratio of their surface area is 1:4. So let the side of the first cube be S1, let its surface area be capital S1, and let its volume be V1. Take the second cube, let its side be S2, its surface be capital S2, and let its volume be V2. And what does this say? S1 by S2 is equal to 1 by 4. But what is S1 by S2? It is 6 S1 square by 6 S2 square. This is equal to 1 by 4. So that means S1 square by S2 square is equal to 1 by 4. And what does that mean? Take square root over everything. Do not worry about negative values. Here we are talking about measurement, right? So measurement cannot be negative. So just take the positive root. So S1 by S2 is 1 by 2. Now we want the volume ratio of the volumes. What is that? V1 by V2, that is S1 cube by S2 cube. But then what is S1 by S2? That is 1 by 2. So that means the first volume is to second volume is 1:8. If the surface areas are in the ratio 1:4, the volumes will be in the ratio 1:8. Now, another one new concept which you have not learnt with rectangles that you learn here, it is the concept of capacity. How much something can hold. So usually that is the volume, right? And volume is measured in centimeter cube. That means suppose you have a water tank, and if I say its volume is say 800 or 8000 centimeter cube, that means it can hold up to 8000 centimeter cube. But then, is that how we measure liquids? What do we measure liquids in? In liters, milliliters, kiloliters. Then how do I connect this centimeter cube with liters? So we have a formula for that. And what is that formula? 1 centimeter cube is equal to 1 milliliter. Now multiply both sides by 1000. You have 1000 centimeter cube is equal to 1000 milliliter. But what is 1000 milliliter? It is 1 liter. So this is how it is connected. So 1 centimeter cube is 1 milliliter. 1000 centimeter cube is 1 liter. So here we have 8000 centimeter cube. That means this is the same as 8 into 1000 centimeter cube. That means this particular tank can hold 8 liters. What about meter cube? We can find that also. What is 1 meter cube? 1 meter cube is 1 meter into 1 meter into 1 meter. That is what any cube means, right? A number multiplied with itself 3 times. But what is 1 meter? It is 100 centimeter into 100 centimeter into 100 centimeter. So how many zeros do you have here? You have 6 centimeter cube. But then see here, you take 1000 centimeter cube, you actually have 1 liter. So this is equal to 1000 liters. So what is 1000 liters? 1 kiloliter. So that is the third formula we are learning today, which is 1 meter cube is equal to 1 kiloliter. So this is how you connect centimeter cube and meter cube to milliliters, liters and kiloliters. 1 centimeter cube will be 1 milliliter and 1 meter cube will be 1 kiloliter. Now let us do some problems based on this concept. Now I have written down just the basic information about the two questions. Now come to the first question. What do you have? You have the volume and you have the length, you have the breadth, but you do not have the height. So call it h. So then what do? You apply the formula. The formula is what? V is L into B into H. But do you notice one thing? The volume is given in liters, but then the length and the breadth are given in meters. We cannot have two different units in one equation. We have to make it same. So we will change this 24,000 liters into meter cube. How many meter cube is that? 1000 liters is, any 1000 is kiloliter, right? So do you remember? 1 kiloliter is 1 meter cube. So 24,000 liters is actually 24 meter cube. Now substitute that here. Your volume is actually 24 meter cube. Length is 8. Breadth is 3. And H you don't know. Now cross multiply, you get 24 by 8 into 3, that is equal to 1 meter. The height will be 1 meter. Now what is the next question? You have a tank. That tank can hold 108 meter cube of water. And the water is pouring in. At what speed is the water pouring in? Time and volume. 60 liters per minute. So in 1 minute 60 liters of water is coming. But then how much water can it hold? It can hold 108 meter cube. So to fill this much, how much time? Suppose it is x minutes. So again, do you see what is wrong here? One you have liter and the other you have meter cube. You cannot have two different units. You have to make it into the same one. Which one can you change? Now 1 meter cube is equal to what? It is 1000 liters. So now you have the same unit, right? Now cross multiply. Do not cross multiply when they have time. Both should be minutes. Volume, both should be liters. Liters or meter cube or whatever it is. But the unit should be same. Here it should be the same unit of time, the same unit of volume. Cross multiply. 60 into x will be equal to 108 into 1000 liters. That is x will be equal to 108 into 1000 by 60. That would be cut. So this much minutes. So this much minutes is too much to calculate in minutes, no? So how many hours? It would be 60 minutes. 1 is equal to 1 hour. Then 1800 minutes is how many hours? Again, cross multiply. That would be 30 hours. So for this particular water tank to fill, it will take 30 hours. Now you have a room. Its perimeter and its height are given, and you have to paint the walls of the room. What does walls of the room mean? You are talking about the lateral surface area. You don't have to worry about the roof, and you don't have to worry about the floor. So what is the lateral surface area? It is 2 times h into L plus B. But then, what is 2 times L into B? You remember the perimeter? Perimeter is 2 into L plus B. So, this is in other words height into perimeter. That means it is 6 into 250 meter square. And that would be 0 carry over 3. This much meter square. Now, what is the cost of painting it? For every 1 meter square, the cost is 20 rupees. But then, how many meter square do you have here? You have 1500 meter square. So, how much rupees it will be? X rupees. Cross multiply, then you will get x is equal to 1500 into 20. That means this much rupees you will need. You will need 30,000 rupees to paint or whitewash or whatever it is to do with this wall. And what is the second question? You have a open box. It is a cube and its sides are 1 meter. Then what is its total surface area? So what do you have here? You have a cube. But then what is missing? Its top is missing. It is an open box. So you lose one side. And how many squares are left? 5 squares are left. So its surface area is 5 into a square. That is 5 into 1 meter square. That is 5 meter square. So with this you can think of any number of situations. Now suppose if it is a room and you have to paint the walls. So only consider the lateral surface area. Or you have to put tiles on the floor. Then what? Only this. You have to worry only about the floor. So you don't have to consider anything else. In this, what are you doing? We are considering a open box. That means the top is gone. The remaining 5 rectangles are there. So depending on the situation, we just keep losing faces. Out of the 6 faces, we just keep losing faces depending on what the situation is. Now look at the 5th question. You have a cube. And what is its side? Its side is 6. And now 2 such cubes are joined face to face. So here you have a cube and you put another cube side like this. Okay. Now what is the new surface area? Imagine another cube just like this. Then what will change? Will the height change? The same height, no? The height will not change. will the breadth change? No, the breadth will also not change. But what will change? The length. The length now becomes 2 times, right? So consider the cube. What are its dimensions? 6 centimeter, 6 centimeter, 6 centimeter. So whether you put side to side or one on top of another, any one dimension will change. In this case, you are putting side to side, so the length will become double. But if you are putting one on top of another, then what will happen? The height will become 2 times. Depending on where you are putting the other box, either the length or the height or the breadth will change. So here what is changing? You are putting another one book or box just like this here. So therefore the length will become double, the breadth will not change, the height will not change. So now what was a cube has now become a cuboid. That would be 72 centimeters plus 36 centimeters plus 72 centimeters. So that's all for today. So when you see such questions, please try to understand what do they want you to find. Is it the surface area? Surface area is something which deals just with the surface. So painting, whitewashing, all of that falls under surface area. And what about the volume? Anything that can hold. For example, a big box, you have a big box and how many small boxes can fit into it. So what do? Find the volume of the big box, then the volume of the small box, and suppose the volume of the big box is say 25 centimeter cube and this one is suppose 5 centimeter cube. So that means you can put 5 such boxes in this big box. So anything that holds is volume. And the same, another volume question that you can expect is about putting bricks on a road. So same thing. Suppose a road, you are given the dimensions of a road and its volume comes up to 25 centimeter cube and the volume of one brick is say 5 centimeter cube. So how many such bricks can you put here? Same thing, volume of the road divided by the volume of the brick. So just read the question carefully and try to understand what it is asking, and similarly be careful about the units. Make sure all the quantities given are in the same unit. So till I meet you next time, you take care. Assalamu alaikum.